Hello everybody, welcome to lesson 5. So this is the last lesson in this first chapter. And like I said, most of this should feel like review to you. It should just be kind of solidifying some ideas and building some confidence before we move on to more things. Today, we're going to work on simplifying algebraic expressions. We've evaluated expressions by using order of operations, but today we're going to start throwing in some variables. Okay, now to simplify algebraic expressions, I usually teach it with just 2 steps. Use the distributive property wherever you can, and then combine all your like terms. Okay, well, we already know how to distribute. We talked about that last class. We need to discuss combining like terms. So the next natural question is, what are like terms? And well, more pointed, what are terms? Okay, what are terms? So let me give you, just by way of explaining, let me write down a big algebraic expression, and let's talk about what terms are. Those are ugly to use. I haven't been able to draw them very nicely. I think I made them worse, but we can pretend they look better. Alright, so now let's look at this, and I was going to try to explain to you just visually what a term is. So terms are everything around the pluses and minuses. So these pluses and minuses are what, I'm going to draw these and erase them, are what divides the terms. So in each box here is a term. 3x squared, 5xy, 6x, 7x squared, 5y squared, 9. Those are the terms. Let me undo all that. So pluses and minuses give us a little stop sign to say this is a term, stop. This is a term, stop. This is a term, this is a term. So the pluses and minuses divide out our terms. So we see I have 1, 2, 3, 4, 5, 6 terms here. Okay. Now, the glue that holds pieces of a term, I looked at this one. This one has a 5, an x, and a y. There's understood to be multiplications in between here. Multiplications hold together the pieces of a term. So 5xy is all one term. It's made up of 3 pieces, but it's all one term. Okay, so I have these terms here. Okay, so these are terms. The next question is, what makes them like? Well, to be like, they need each term, if they're going to be like, needs to have the same variables. Raised to the same exponents. And let me try to show or explain this exponent. Let me focus on spelling first. Exponents. I'm horrible at spelling, and if I try to talk and write, I'll have to mess up. So the same variables raised to the same exponent. So 3x squared, to be another like term, it has to have an x squared and only an x squared. Of course, it can have a number out front. Does anybody know what the numbers? While we're here, let's throw some more terminology. A number out front of the variables is called a coefficient. So 3, 5, 6, 7, 5, 9. But they have to have the same letter part with x. So I need something else to have an x squared. So this one has an x, but it's not an x squared. It also has a y, so this is not like this one. This one has an x, but it's not an x squared. So these two are not like. This one, though, this one has an x squared and only an x squared. It is like this one. Okay? This one has a squared, but it's the wrong letter. It's a y squared. This one is a 9. So they have to have the same letters, and they have to be raised to the same exponents to be like. So let me scroll back up to my directions. Distribute. There's nothing to distribute here. I see no parentheses. And combine like terms. My like terms are 3x squared plus 7x squared. So I can use the commutative property and associative property to make it so that if I were to rewrite this to simplify it, I'm going to move these two together, all because they're like, now I have to still have the whole entire rest of the expression here, but I put together which ones are like. I rearrange. We usually do this in our heads, but just to show you, and then I can actually add the coefficients, or whatever operation, subtract or add the coefficients. 3 plus 7 is 10, and that would make 10x squared plus the rest of this. So notice I leave the exponent and the base alone whenever I combine my like terms. 3x squared, 7x squared, that becomes 10x squared, because they have to have the same variables and exponents, and then I combine them and they're still the same variable and exponents. So that's kind of like, wait, that's done for the lesson today. Not really, we have to do examples, but that's all you need to know. So let's jump into examples and see if you can simplify these algebraic expressions. And we're going to keep just doing this as 2 steps. Distribute whatever we can distribute, and then combine anything that's like. Okay, so it's kind of like Washington D.C. There's 2 steps: distribute, combine. So look at this first one. There are no parentheses, so there's nothing to distribute. Now, I do have some like terms. I have 15x squared. Let's see, are there any other x squareds? Oh, right here. Minus 3x squared. So I could take the time and rewrite it so that they're beside each other, and then do 15 minus 3 or plus negative 3, whichever way you like to think of it. But I think we're smart enough to just be able to say, alright, well 15x squared and minus 3x squared are like terms. 15 minus 3 is 12, so I have 12x squared plus 8 minus 6. Well, 8 and 6 are just plain numbers, right? So by default, they don't have a variable or an exponent, so they are like terms. So 8 minus 6, that will be 2. So I have distributed everything I sought to distribute, then I combined all the like terms that I had to combine, so I have simplified that expression. I am finished with it. Do not try to combine things that are not like. Do not tell me this is 14x squared. These two cannot be added because this has an x squared, this does not. Okay, let's do another example. How about diving into some stuff we've done before? 2/5 h minus 1/2 h. This one's quite simple to distribute and combine because there's nothing to distribute. We go to combine and there's only 2 terms and they're both like because they both are just a plain h. So then I just need a handle. 2/5 minus 1/2. So I'm going to need to do some scratch work to be able to handle this. Now I could type this in a calculator to do it. You would need to have parentheses around each fraction and be really careful. But let's do it by hand just to practice. So notice this is adding or subtracting fractions, so that means I need the same denominator. 5 and 2 are not the same. So let's get them both to a number they can reach. They both can be multiplied up to 10, right? So 2 times 2 is 4. 2 times 5 is 10. So I could rewrite 2/5 as an equivalent fraction of 4/10. Bring down our operation. Let's see, how can I get 2 up to 10? I can multiply by 5. Now remember the rule, whatever I multiply the bottom of a fraction by, I got to multiply the top of it. So 1 times 5 is 5. 2 times 5 is 10. So I have 4/10 minus 5/10. Now they have the same denominator. So whatever they add or subtract to will be over 10. So 4 minus 5 over 10. That's just negative 1 over 10. Okay, so I can take 2/5 minus 1/2, and it is negative 1/10. Now they both have an h, so this term is still h. So negative 1/10 h. That was maybe, don't get lost, kind of the forest for the trees thing. Don't get lost in our scratch work. You can just do that in a calculator. All right, let's keep simplifying. Let's try to find one that maybe is going to take more than just combining, a few more steps. Keep building here. So here's what we got. So this time I look and I actually finally get to use step 1, distribute. So I see 2 sets of parentheses to distribute. So let's start with the first one. 3 times x is 3x. And 3 times 3, bring down my plus sign. 3 times 3 is 9. Alright, that's good. Let's see, bring down this plus sign. Let's distribute the second parenthesis. 2 times 9 is 18. And 2 times 9, notice this is a minus 5x. So that's going to be minus 10x. Okay, so notice I did not do any combining yet. I wanted to do all the distributing that I can. That's the first step, is to distribute, then we combine. So let's see if we have any like terms. Well, I have a 3x, I have an x term. Oh, and I have a minus 10x, that's another x term. So those are like. And so let's go ahead and do those. 3x minus 10x, 3 minus 10, that is negative 7x. And then I have plus 9 plus 18. Those are like terms as well. So plus 9 plus 18, that is plus, what is that? 27. Now these are not like. This one has an x, this one doesn't. So I cannot combine them. So I'm finished. Okay. Hopefully you think this is not too nasty or too bad. I think it's kind of enjoyable. Let's do another example. Let's see. Maybe 2 more examples. 6m minus 5 minus parentheses 4 minus 2m close parentheses. This is a type that people get wrong a whole bunch, and I'll show you why. The first step is to distribute, and we look and we see, yeah, we have parentheses, but a lot of people are tempted to distribute this 5 because there's no number right out front here. Y'all see that? There's no number. We can understand it as having a 1 there, but what we're really needing to distribute, that's a horrible 1. What we're really needing to distribute is this subtraction, this negative sign. So it's like distributing negative 1 into both of these. So let's bring down all the stuff that we don't need. So we'll bring down 6m, we're not messing with that. We're actually not messing with minus 5. We need to distribute this subtraction as a negative 1. So a negative 1 times a 4 makes for a negative 4. We're going to write it as a minus 4. A negative 1 times a minus 2m, a minus and a minus makes a plus 2m. So what this does whenever you have a negative or a minus sign right against the parentheses is all it does is flip these signs. So notice this was a positive 4, it became a minus 4. This was a minus 2m, it becomes a plus 2m. All because of this. There's no number there to change these values, but the signs get flipped. So now I've distributed. Notice I drop the parentheses after I distribute each time. Now that I've used up those parentheses, I can combine my like terms. And I have 6m and a plus 2m. That makes for an 8m. And I have minus 4, minus 5. That makes for minus 9. Okay. So let's do one more. One more that's kind of a one. You'll be able to see several versions very similar to this on all the versions of the test. Let's go with 1/2 parentheses 12x minus 20 close parentheses plus 1/3 parentheses 6x plus 12. Alright, and we still are doing these, that simplifying in the same 2 steps, distribute then combine. So this is actually, it looks intimidating because people see fractions and they get a little nervous. But it's actually quite easy. We made these to be pretty. They're not going to be nasty fractions. So I take 1/2 and I need to distribute it. 1/2 times 12x. Well, what is 1/2 times 12? Remember, I need to put a 1 on the bottom and multiply straight across. That's just 12 divided by 2, which is just 6. So this will be 6x distributed into this minus 20. If you do go through the same steps, or use your calculator, I'll be your calculator for you. Multiplying by half just halves it. What's half of 20? 10. Notice half of 12 is 6. Now let's do the same thing with this 1/3. Multiplying by a third will just third it. What's a third of 6? It's 2x. If you did want to take the time to multiply these out, that is 6 over 3. 6 divided by 3 is 2. And the same thing here. A third of 12 happens to be 4. So while that looks confusing and difficult, it's actually quite simple if you get used to multiplying by fractions. So now I can just combine my like terms. 6x plus 2x. Always look at the sign directly in front of numbers. No sign here, so it's positive. We're adding a positive 2x. That makes 8x. This is a minus 10. Look directly in front of it. Belongs to the number. And a plus 4. Negative 10 plus 4 will give us a negative 6, or a minus 6. Okay? So that's all I have for you. Look out for announcements on the test, because the next thing we need to do now is take test 1. I'll be sending some emails or alerting you to that, or I may have already sent you an email, depending on when I finish recording this and post this. So anyways, have a good day, and I'll see you later.